lecture, we were discussing about the graphical analysis of the motion. In the last of the lecture yesterday, we discussed about the different types of graphs representing different types of motion. Now discuss some more points in this graphical analysis of the motion. See here. In the graph, distance time or position time or displacement time. Distance time graph, time represented along x-axis and distance or position or displacement represented along y-axis, and suppose the motion is uniform. For the uniform motion you will get the straight line inclined on time axis. So the slope of this graph will represent the velocity, means the velocity of the motion or speed of the motion. And slope, what is slope? Let's define here. What is slope of the line? Slope of the line means tangent of the angle of inclination of the line on time axis or x-axis. See here, slope means in class 10th you have learned about the trigonometry, and tangent was there. Tangent is one of the 6 trigonometrical ratios. If this is theta, suppose there is a point P here. When we are drawing perpendicular line from this P to this x-axis, so in this triangle tan theta equals to, suppose this is AO and this is A. So tan theta of this triangle is equal to perpendicular upon base, so it is AP upon OA. That is equals to tan theta, and this tan theta is called slope of the line, and this slope of the line indicates in this distance time graph the velocity of the uniform velocity of the body. Repeating, in distance time graph, when the motion of the body is uniform, then you will get the straight line inclined on time axis, and the slope of this line will represent the uniform velocity or speed or velocity of the body, and that is equals to tan theta, and tan theta applying in this triangle will equals to AP upon OA, that is perpendicular upon base. So this is about the slope of the line. In case first when object is at rest, now see here, suppose distance time graph for rest represented by this straight line parallel to the time axis. Now what is the slope of this line here? This is your question. Find the slope of this line here. What is the slope of this line here? And you can send your answer to me, and जो दो स्टूडेंट पहले सही जवाब देंगे उनको मेरी ओर से मिलेंगे nothing, no prize, but I will appreciate him, है ना? So find the slope of this line here. Now next, see next point in this graph, graphical analysis of the motion. Suppose this is one more position time or distance time graph. In this graph, the graph line obtained parabolic shape, and this parabolic shape shows the motion is uniformly accelerated motion. So remember one thing, in position time graph for uniformly accelerated motion, the graph obtained parabolic. And what about the slope of this graph now here? So slope of this graph at different points will shows the different inclination to the time axis. So at different points you will get the different velocities, and that velocities will be instantaneous velocities. So mark here dx upon dt, x along the position and t along the time. So dx upon dt will be the slope of this graph at suppose instant point A. At instant point A, dx upon dt will show the slope of the graph, and that will be the instantaneous velocity. Instantaneous velocity. So this is about the position time graph for uniformly accelerated motion. Now see for velocity time graph. In velocity time graph, when the graph line obtained straight line, it shows uniformly accelerated motion. When the graph line obtained straight line inclined on time axis for velocity time graph, then this graph represents the motion is uniformly accelerated motion, and the slope again here, slope of the graph equals to tan theta, where theta is the inclination angle of the line with time axis. So again mark here any random means random point A and draw the perpendicular on time axis. Suppose point P here. So tan theta for this triangle is perpendicular upon base. Perpendicular is AP, and what is base? OP. This will give you the acceleration, uniform acceleration of the body. Uniform acceleration of the body here. And also you can write here AP. What is AP? AP means this height. This height means difference of V and 0. V and 0 difference means the change in velocity. That is V minus 0, change in velocity. And OP means, this is T, suppose time T. OP means difference of T and 0. T minus 0. So see here, numerator is change in velocity, denominator is time interval. So this is called acceleration, rate of change of velocity here. Now our next topic is relative velocity. This is the last topic of this chapter, relative velocity, and it was very interesting also. It will help you to solve the numerical problems in your exercise. See here, what is relative velocity? It is very common to experience the relative velocity. Suppose you are sitting in the moving bus. एक मूविंग बस में बैठे हो और साइड से एक दूसरी व्हीकल अगर क्रॉस करके आपको निकलती है, तो the speed of the other vehicle experiencing by you is the relative velocity of other object. See here, relative velocity. One more example you can think about this example. कि suppose other vehicle is crossing to your vehicle by moving along the same direction, और दूसरा केस है when the other vehicle is crossing your vehicle by opposite direction. In both cases the relative velocity appears differently. When the other vehicle is crossing your vehicle by your direction, by the same direction, then the other vehicle's speed appears slow. But if the other vehicle is crossing your vehicle by opposite direction, then the other vehicle speed appears more. So this is all about the relative velocity. Now see here, what is the situation? Let's define first what is relative velocity. Relative velocity of second object with respect to first object is the time rate of change of position of second object with respect to first object. Repeating, relative velocity of second object with respect to first object is the time rate of change of position of second object with respect to first object. This is relative velocity. See here, this is object 1 moving with velocity v1, another object moving along the same direction with velocity v2. They have their constant velocities v1 and v2. Both are moving in uniform motion with different velocities v1 and v2. Now suppose the coordinates of I'm going to apply the kinematic equation. I am writing here x equals to x0 plus vt. We have discussed about this relation. This is called kinematic equation for uniform motion. So let's apply this equation to both of this object. Suppose listen, x0, this is x0 and x1 I am marking here. x10 and x20 are the position coordinates of object 1 and object 2 in time t, at time t equals to 0. x10 and x20 are the position coordinates of, मतलब ये सब क्या है, initial points हैं, initial points के coordinate हैं. x10 and x20 are the position coordinates of the object at time t equals to 0. मतलब ये हो गए दोनों initial positions. And x1t and x2t are the position coordinates of the objects at time t equals to t, time equals to t. So they are final positions of the object 1 and 2 respectively at time t. So let's apply these two situations in kinematic equation of the bodies of the objects here. So for first object it is x1t equals to x10 plus v1t, and for second object it is x2t equals to x20 plus v2t. See here, you should write here applying kinematic equation. You will write here applying kinematic equation to both of the objects. We have the two relations, equation number 1 and equation number 2. ये बिल्कुल वैसे सिमिलर है काइनेमेटिक इक्वेशन की तरह, बट ये सिचुएशंस बनाई गई हैं. For 0 time it is x10 for first object, x20 is the initial position of the second object, and x1t and x2t are the positions of the object 1 and object 2 at time t. So let's equation number 2 minus equation number 1. Let's do here. We are subtracting equation number 1 from equation number 2. What happens? Let's see. x2t minus x1t is equal to x20. I am arranging also here. x20 minus x10, इन दोनों को साथ में कर लिया, and these two will be together here. So plus v2t minus v1t. See here, subtracting equation number 1 from 2, x2t minus x1t equals to x20 minus x10 plus v2t minus v1t. Or let's call these two terms in left side, and arranging the terms we have x2t minus x20. This term will come to this left side with plus sign, so plus x10 minus this term now x1t is equal to taking common t here, so it is v2 minus v1 t. Now let's see. I'm writing here the next step. x2t minus x2 0. What is this? x2t minus x2 0 is the displacement of the second object in time t. This is displacement of object 2 in time t. I am not writing here, but this sense as displacement of object 2 in time t. And now what about these two terms? Now let's taking minus sign common from these two. माइनस कॉमन लिया, क्या बना? x1t माइनस x10. इन दोनों में से माइनस कॉमन लिया, सो x1t माइनस x10 इज इक्वल टू v2 माइनस v1 t. Again, displacement of object 2 in time t minus, see here also x1t minus x10, final position minus initial position. It is also displacement of object 1 in time t. In time t is equal to here v2 minus v1 into t. Now see here, displacement of object 2 in time t minus displacement of object 1 in time t. The difference of these two will give you the relative displacement. So here, relative displacement of object 2 with respect to object 1. Difference of these two will give you the relative displacement of object 2 with respect to object 1. It is equals to v2 minus v1 into t. Now let's see. Let's bring this t in left side by cross multiplication. Now see here, relative displacement of object 2 with respect to object 1 divided by t is equal to v2 minus v1. By bringing the t from right side, it comes in denominator of the left side. So see here, numerator is relative displacement or denominator is time. So this is relative velocity. So this is relative velocity of object 2 with respect to object 1. It is equals to v2 minus v1, and this relative velocity of object 2 with respect to object 1 is represented by v21. See here, this is the expression for relative velocity when the two objects are moving in the same direction, along the same direction, and having the uniform velocities v1 and v2. Similarly, you can write the relative velocity of object 1 with respect to object 2. It is given by v12 equals to v1 minus v2. See here, let's see the example. Suppose a bus is moving along the positive direction of x-axis with 30 meter per second. Another object is also moving along the same direction with 20 meter per second. Suppose this is 1 and this is 2. So the relative velocity of 2 with respect to 1, इसका मतलब पहले में बैठे हुए दूसरे की स्पीड को जो ऑब्जर्व करोगे, एक्सपीरियंस करोगे, that is v21, relative velocity of 2 with respect to 1, it is equals to, by the formula, v2 minus v1, this is 20 minus 30, it is equals to minus 10 meter per second. अच्छा, first thing, it should be more than first for crossing the first. So suppose this is 10 and now this is 20. इस सेकेंड ऑब्जेक्ट को अगर पीछे है फर्स्ट को क्रॉस करना है तो इट शुड हैव मोर स्पीड देन फर्स्ट. सो नाउ सी हियर अगेन v21 इक्वल्स टू 20 minus 10, it is equals to 10 meter per second. इसका क्या मतलब हुआ कि the person sitting in the first bus observing the second object moving with speed 10 meter per second. It is not its actual is 20, but appearing, means observing 10 meter per second only. Now see here again, second example. First object moving with velocity, suppose 10 meter per second. Second object moving along opposite direction with speed, suppose here 20 meter per second, or suppose less than 10, 5 meter per second. Now, and suppose this is object 1, object 2. So relative velocity of 2 with respect to 1, relative velocity of 2 with respect to 1 means you are sitting in the first bus and you are observing the speed of the second. Then speed of the second observing by you is relative velocity of second with respect to 1. It is equals to again v2 minus v1, this is v2, but see here, this is going towards positive direction, so we are taking it positive, and this is moving opposite to the direction of first, that is towards negative direction of x-axis, so it will be negative. So v2 minus v1, v2 is 5, but we will write minus 5. Why minus 5? Because it is moving towards negative direction, opposite to the first. ये सब क्यों कर रहे हैं? साइन का कन्वेंशन यहाँ क्यों लगा रहे हैं? Because velocity is a vector quantity, not scalar. So we will write the sign also. So minus 5 minus, what is v1? v1 is 10, and minus 5 minus 10, it is equals to minus 15 meter per second. So see here, minus 15 meter per second is the relative velocity of second with respect to 1. मतलब पहले में बैठे हुए दूसरे को ऑब्जर्व करोगे तो it will appear 15 meter per second. That is much more than the actual speed of the second. And negative sign shows it is moving towards opposite direction of first. So this is the effect of relative velocity. So one more topic remaining in this chapter, that is position time graph for the relative velocity. So it will discuss on Monday, and it's your work to start the numerical problem solving of this exercise. You can start the solution of the solving of numerical problem of your NCERT book of this chapter. So for today's lecture, thank you very much and God bless you. Keeps learning.